Hello everyone, this is Kumo Nena. Nena this. A math guy with some math life. This is my first math video. In this video, I'm going to introduce how people in Mesopotamia solved the simultaneous equations. Elementary algebra is dealing with Latin letters and Greek letters, known as variables. When we want to introduce relationships, we use sentences. But in algebra, we use equations. For example, let's see this question. Adam has some marbles. Bradley has twice as many marbles as Adam. Chris has 5 more marbles than Bradley. In total, they have 55 marbles. How many marbles does Chris have? This is a typical Gracie secondary school math question about forming and solving equations. If we want to use algebra to rewrite these full sentences, we first assume that Adam has x marbles, so Bradley has 2x marbles, and Chris has 2x plus 5 marbles. From the full sentence, we can get the equation x plus 2x plus 2x plus 5 is 55. And then we need to solve this equation and further find the answer to this question. I guess many of you can give me the answer within a minute. For those who want to have a go on this question, the answer is 25 by the way. There are many fascinating stories in Mesopotamia. So, what about their math? What did people in ancient Mesopotamia do to solve such a problem? To answer this question, we first need to know how they represented numbers. During that time, people used the cuneiform text to write. Cuneiform was originally used to write the Sumerian language of southern Mesopotamia, which is now in Iraq. It is the earliest writing system. The word cuneiform made by blending cuneus and form. It means wedge-shaped. From the earliest Sumerian clay tablets around 3200 BC, we can see that they had already used the decimal and sexagesimal system. The sexagesimal system was an ancient system of counting and calculation. It used the powers of 60, while the decimal system uses powers of 10. Do we still use sexagesimal system now? Yes, we do. We still use it to measure time and angles. Why did the Sumerians love to use a base 60 system? The reason for the choice of base 60 is not obvious. Some people say that it is because 60 has 12 factors. 1, 2, 3, 4, 5, 6, 10, 12, 15, 20, 30, and 60. 60 has more factors than 10. So, it is easier to divide. But did people really worry about the divisibility of numbers at that time? We're not very sure. Maybe they just wanted to use it to count the number of days and nights in a lunar month. As a child, we use our fingers to count 10. We can still use our hands to count 60. Let's see my hands. Each finger has 3 bones. I'm going to use my left thumb as a pointer, although I can't really show you guys how I move my thumb. There are 12 bones on the other 4 fingers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now I get 12, and then I use the right thumb, like this. In other words, each finger of my right hand means a set of 12. So, altogether, I can count till 12 times 5, which is 60. When people wrote on a clay tablet, the tablet was soft. They held a tablet in one hand and held a reed in the other hand to write. I can't show you how they did that, so I will just draw a clay tablet here. If you want to see the picture of a real one, please go to the description below to see the links. On the clay tablet, this semicircle shape means 1, and this circle represents 10. The slightly bigger semicircle means 60, and this slightly bigger circle means 3600. A small circle and a big semicircle gave us 600, and a small circle and a big circle gave us 36,000. We can use these 6 symbols to represent the other numbers. Around the middle of the 3rd millennium BC, Babylonians invented a similar numeral system. Let's see how they wrote numbers. This means 1, and we can continue adding this. So 2, 3, 4, 5, 6, 7, 8, 9. When we get 9, we use this to represent 10. Once we get 60, we draw a slightly bigger one. So we need to have a place value system. For example, this is a 3-digit number in the sexagesimal system. It is 2 times 3600 plus 10 times 60 plus 10, which is 7810 in the base 10 system. What did Babylonians do if they needed to write a 0? They used the empty space between digits to represent the 0, but this could cause some problems. They didn't have an exact length for the gap, and it's impossible to represent a number with final zeros. And so, this 110 in the sexagesimal system and this 11 looks the same. There was no symbol for 0 until about 300 BC. Now let us see how Babylonians solved the simultaneous equations. Here is the question. I have two fields. The first field gave 4 kg per bar. The second field gave 3 kg per bar. The first field gave 500 more sila than the second. In total, the areas of these two fields is 1,800 sa. What is the area of each field? Ka, bar, sa, and sila are ancient Mesopotamia units of measurement. Bar and sa are area units. 1 bar is 1,800 sa. 1 sa is about 36 meters squared. Ka and sila are volume units. 1 ka is 300 sila. 1 sila is around 1 liter. To solve this question, we need to have the same units. So, 4 ka per bar is 1,200 sila per 1,800 sa, and 3 ka per bar is 900 sila per 1,800 sa. To get the grain volume per sa for each field, we need to divide 1,200 by 1,800 to get the yield of the first field, which is 2/3 sila per sa. And similarly, the yield of the second field is 900 divided by 1,800, which is 1/2 sila per sa. Babylonians called the yield of each field per sa the fourth grain. To make it clear, we will use modern math notation to explain. Let the area of the first field be XR and let the area of the second field be YSR. Then the total area gives us x plus y equals 1,800. The difference between the total production of two fields gives us the second equation. 2/3 times x minus 1/2 times y equals 500. The method we learned at school is called elimination. To apply this method, we need to rearrange the first equation and get expression of y in terms of x and substitute it into the second equation. But Babylonians used a different method. They first took a new variable, z equals half of x minus y. Since half of the sum of the areas of these two fields is 900, we get a new equation. Half of x plus y is 900. If we add equation 3 and equation 4, we get x equals 900 plus z. If we subtract these two equations, we get y equals 900 minus z. Now we substitute these two expressions into equation 2. Equation 2 becomes 2/3 times 900 plus z minus 1/2 times 900 minus z equals 500. By expanding brackets and simplifying, we get 150 plus 7/6z equals 500. So 7/6z is 350, and so z is 300. Therefore, we get the values of x and y. X is 1,200 and y is 600. Problem solved. What do you think about this method? This was not the only method they used to solve such a problem, but it was the most common one. People still used this method after Mesopotamia. Okay, this is the end of my first math video. I hope you like it. Thanks for watching. I will see you in the next video.